Hey there, fellow game devs. In this video, I'll be taking a look at a database-backed user login system. This example is going to use the Unreal Engine and will focus on SQLite for ease of use. However, this particular example could use almost any SQL database, including client-server ones, such as MySQL, PostgreSQL, SQLServer, or Oracle, with little to no changes needed. Before we get into it, let's have a quick word about security. Any system with a password is basically a system which is attempting to perform some kind of security, and I really didn't want to get into a discussion about security matters. I'd rather focus on how we can make great games. So that's basically the caveat for this video. I will mention some aspects of security, because for certain things I just can't stop myself. But I don't want to make it the main focus. I'll discuss making a local user login system using SQLite, the kind of thing that would allow many people to all play the same game on the same computer, but each keep their specific progress private. The basic principles are pretty much the same when you extend it to client-server databases though, so it should form a useful background if you want to take your databases online. The queries will be similar if not the same, and the example UI elements would be pretty much identical. Okay, enough waffle. Let's get on with it. Let's begin by considering the database. For any system that will perform a user login function, we're probably going to need a table to store user data. The precise data you want to store will vary depending on the kind of functions you wish to use that data for. As discussed in the previous videos, we want a unique value for the primary key. I'm going to keep it simple and just use an automatically assigned integer, and I'll give it the rather unimaginative title of user ID. The user ID is just something we will use to connect any related tables in our database, and it's not something we will ever display directly to the player. This is not really important in the local scenario that we're using here, but it is a security concern having online databases shared by many players. Don't let potential cheats or hackers have any information that they don't absolutely need to play the game. So in addition to the user ID, we probably want to have something we can show the player. A nickname, username, or handle, whatever you like to call it. Some people will naturally want to make that username the unique primary key. After all, we generally don't want to let several players all have the same username. Personally, I consider using the username as primary key a bad idea. If the account name is the primary key, it means that full name is the thing which will be included as a foreign key in all the linked tables, which may not sound like much, but if you allow, for example, a 20-character username, then that's going to be up to 20 bytes or 40 on a Unicode system taken in every single associated table for every single associated record. Whereas, a simple 4-byte integer will always take exactly 4 bytes and give you over 4 billion unique user ID values. If you have more than 4 billion players, congratulations. You can more than likely now afford to go and pay someone else to consider all this stuff for you. Go and have a holiday. Go on, you deserve it. Secondly, if you use separate username and user ID, even if your system does enforce users to have unique names, it will allow you to let them change their name at any time, as long as the new name is also unique. And the only thing which needs to be changed is the text in the user table. Even if you don't normally allow players to change their username, setting it up this way also allows for a username to be easily changed by admins should you discover down the line that a user has entered a name that breaks your permitted use policy, for example. So we have user ID and we have username. In this implementation, I will make the name the user provides unique, so that no two users can have the same name. I'll do this by specifying unique for the field, or ticking this little box right here if you're using DB Browser for SQLite. Probably the final mandatory field is going to be something for the password. So let's take a moment to talk about storing passwords. Don't. Seriously, don't ever do it. If you've never written any kind of logon system before, you may not be familiar with this point. We never, ever store passwords, because if we did, they could get stolen by hackers, or the database admins could dump them onto thumb drives and sell them on the dark web, whatever that is. So how the heck do we check a password a user enters is the right thing if we didn't store the user's password when we created their account? We use a programming concept known as hashing. If you already know what that is, great, but many self-taught programmers and indie devs don't, so I'll quickly describe it here and give you a link in the video description so you could find out more. And you really should, because it's one of those fundamental programming building block type things that all programmers really ought to know about. So, hash functions are code that take data as an input and produce a key from it. The data can be pretty much anything you like, an entire file, a series of numbers, an image, even some text, like a password, for example. The data goes in and the key comes out. There are different standard hashing functions used for different things that work in different ways, but for different inputs, you always get different outputs. Yes, there is a chance of getting the same output for different inputs. That's called a collision, but it's incredibly unlikely, especially with modern hash functions. So, if you have the output, that hashed key, you can't use it to generate the data which went in. It's a one-way deal. Having the hashed value does not let you work out what the password is. It does, however, allow a user to come back later, enter their password again, and after hashing it the same way, compare it to the previously stored hash. If they're the same, then the login is successful. You can write your own hashing function, but you probably shouldn't. There are very clever people who have done all that for you, instead of spending their time writing games. Crazy, I know, but true. Seriously though, mainstream hashing algorithms are generally published openly, substantially peer-reviewed, and the implementations tested every which way to Friday. It's not only unlikely that you could produce something as good, but you want to spend your time making games, remember? So stick to that. So, there are a bunch of methods we can use to hash passwords, provided by various libraries, depending on what language we're programming in or the platforms we're targeting. As this is focused on the Unreal Engine, I made a quick scan of the Epic Online documentation and found that the engine comes with built-in functions supporting the Blake 3 cryptographic hashing function. It's not an algorithm I've ever used before, but as it comes with the engine, I'll take a crack at using it. So, let's add another field to the table called password hash. And I'll add one more field, which we'll use as an example of any other user-provided data that you might want to store. I'm going to call this one tagline, and it will be a short piece of text associated with the user, something like an inspirational quote. That's obviously not super important required data, so I'll set the column to nullable. You can add whatever additional fields you require for your specific needs, or create more tables to store that data and simply relate the records back to the user table via the user ID. When thinking about what data to store, consider trying to squeeze as much personal user data out of your users as you possibly can. And don't worry if what you ask for has nothing to do with your specific game or gaming in general. Squeeze every last drop of personal data from your users, and in fact, don't even let them play your game until they have consented that you can do whatever you want with their data. Hide the whole game behind some wall of legal terms and conditions that must be agreed to before they can even get to the gameplay. Then you can sit back and sell that data to every marketing company you can find, which is so much easier and better than concentrating on actually trying to make a good game, just like the big professional game publishers do. And you want to be professional, right? So, we have a basic user table now. What's next? Well, we will need some database queries to support the actions we want. Because I will be using my SQLite framework, each of these queries will be stored in a database table called queries and grouped together under the group name user. Probably the first step a user will take is creating a new account. We do that by inserting the values which they provide into the user table. The first line in parentheses tells the database engine which fields we are supplying values for. After the values clause, you can have one or more lines specifying values that you wish to insert, one line for each new record. In this case, we only wish to insert a single new record, and we supply the values by using query parameters, which we will fill with values when we run the query. The final line uses a returning clause. This is not standard SQL. It's an extension, something which SQLite has borrowed from PostgreSQL. It allows action queries, inserts, updates, and deletes to return data to the caller based on the rows which the query has affected. This can be very useful in allowing us to perform common operations as a single query instead of needing to run separate selects after each action query. In this case, if the insert is successful, we will get notified of the new user ID that was assigned when the record was created. If it wasn't successful, for example, if the data we provided would violate the unique constraint we placed on the username, then we will get no rows back. When a user tries to log in, we need to compare the password hash generated from what they have just entered with the one we have previously stored in the database. In this case, we simply attempt to select the user's record and filter on both their username and their password hash. What this means is that we will only get back a value if the supplied username and password hash are found together in the user table. If they are, we are given that user's unique user ID. If not, we get no rows back. Given a specific user ID, this query returns the associated details. Depending on your specific use case, you might have several versions of queries like this, returning different types or amounts of information. For example, in an online database scenario where players are aware of each other, you might want to let players look at certain fields in each other's accounts. Think of how a service like Xbox Live allows you to look at other players' profiles, for instance. This is our somewhat contrived example used to demonstrate how we could let a user edit any supplementary details they provided. In this case, it's the tagline that we added to the user table, as well as the actual username itself. The user will have to have already authenticated themselves to get to the place where this query is executed. But just to make sure, let's also include that password hash test again. So we are saying that to edit your account, you need to re-verify your password. That's annoying, I hear you say. Why would you do that? Make the user enter their password all over again? Well, for one thing, to prevent little Jimmy from next door who popped round with his mum from changing your username from Awesome Might of Tastiness 2022 to Smell Like Kippers and Pee-Pee while you are distracted listening to his mother telling you about the latest goings on in her life. More reasonably though, we're going to require password revalidation because although this is SQLite, I want to highlight that if this was a client-server database situation, we would be taking all the necessary security precautions that we could. Obviously, there's a bunch of other security stuff that would need to be in place too, but that's something to discuss another time. Also, note the addition of that returning clause again. Returning sends us one row for each row that was affected by the action query. We're obviously not interested in the specific value of that user ID. After all, we just passed it to the query as a parameter when we ran it. If we get the value returned, we know the data was actually updated. If we get nothing back, then more than likely the password submitted was incorrect. Changing the user's password is pretty similar to what we just did for editing user account details. This time we're passing the hashes for the current password and the new one along with the user's ID. And again, if it works, we will get that user ID sent right back to us so that we know it was successful. There are a number of situations where you might want to delete a user's account or allow the user to opt to delete their own account. Here, we're just saying that as the player is responsible for creating their account, we might as well let them delete it too. And yes, we are going to enforce that password validation thing again. This specific example is a little misleading, unfortunately. It makes it look more simple than it usually is. We delete the user record from the table and return the user ID so we can tell if we were successful. Nothing unusual there. But in a real database situation, your user table is going to be related to a bunch of other tables, which may in turn be further related. After all, that's kind of the whole point of doing this in the first place. And if there are related records in other tables, then you are going to have to do something about those first, because you can't delete the user record while other tables have records which depend on it. What that means is such operations are usually comprised of a series of deletions, starting with the most descended tables and moving up the relationship chain until you finally reach the table where you actually wanted to delete the record in the first place. We now have a user table in our database and a handful of SQL queries to perform various tasks. Just as we did in the previous video, we will be using our data access layer class to handle all our direct communication with the database. Our widget code, in fact any code in our game, will not directly run queries itself, but rather invoke functions we add to the data access layer which will handle that for us. This concept is not something specific to MySQL-like helper framework. It's something which is considered fairly standard industry practice with databases. Code which accesses the database is kept in a layer which is distinct from the rest of your program. There are many reasons we do this, amongst which are security, deployment location, scalability, and doing so might even allow you to move your project to a different database engine with a lot less hassle. Often, there will be a direct one-to-one connection between the queries we write and the functions we add to the data access layer to perform them. But sometimes we will have data access layer functions that perform several queries in a sequence to achieve a given result. And the data access layer can wrap those up all neatly into a single function. We can also use the data access layer functions to perform any other housekeeping, sanity checking, or verification that we want. In the case of our user account functions, the data access layer is being used to make sure that usernames never have any leading or trailing white space, and that a user cannot try to create an account with just spaces, for example. You could also include other checks for minimum password length and things like that. Now that we have our data access layer functions, we can move on to thinking about the UI elements the player will interact with. I'm going to provide this via a series of Unreal widgets. I'm using the Alien Warmonger project we went through in the previous video and just adding to it what we need for our user login tasks. It's on GitHub and I'll put a link in the video description. It's already set up to use MySQLite framework and it has its own Alien Warmonger DB file. Of course, for your own projects, you don't have to use my framework plugin. You can go with the basic plugins from Epic and roll your own code to execute the queries and process the results, if that's what you prefer. So, what widgets will we need and how will we make them? In situations where I'm making widgets, I prefer to use a C++ base class and then an editor-defined blueprint subclass. This, in my opinion, gives the best balance between the strengths of C++ for doing very codey things and the strengths of blueprints in the editor for quickly manipulating visual elements. Unfortunately, if you are writing your game with blueprints alone, then this is something that you can't really do. This doesn't mean you can't achieve the same results, but the way you do it will, in my opinion, feel a little more clunky. So, back to those widgets. I'm going to have 7 widget classes in C++ and then 6 widget blueprints derived from them in the editor. Hang on, why 7 C++ classes and only 6 blueprint widgets? Well, the first class we're going to make is going to be the base class for all of the user account widgets. This way, we can have it include any code that we want to be common for all of the user interface components. In this case, that isn't actually going to be much, but we can override the editor function getPaletteCategory, which allows us to place our widgets together in a category that we define in the editor. This doesn't actually do anything as far as the game is concerned, but it is very useful in larger projects where you may have many widgets and possibly several team members. The alternative is the editor groups everything together in a single category called user created, which quickly fills up and becomes difficult to find anything. Plus, it's kind of cool to put your widgets in their own category. The second thing we can do with the base class is store a convenient pointer to our data access layer instance when the widget is initialized, allowing us to have very easy reference to it when we are coding. In a similar manner, because these widgets will all be dealing with aspects of a user account record, we can make a small class containing the user record data as properties and define a pointer to an instance of such a record in this base widget class. All of our widgets are going to be pretty simple. After all, the functionality is mostly provided by our queries via the data access layer. Just to clarify a point, in the base class I have made for all these widgets, I'm overriding native on initialized, and I mark it as final. What this means is that our individual widget classes can no longer override this method. Instead, I provide a new method on widget initialized, which is called from inside the native on initialized method. This means I can now place any code I want in the base class's native on initialized method and not worry that somebody overriding it in a subclass will forget to call the base class method, while I still provide a method subclasses can override to provide any initialization code they require. In this case, I'm grabbing a pointer to our data access layer instance and storing it in the class's own local property for ease of use by those derived classes. The Create Account widget provides input for the desired username and tagline, plus 2 boxes to enter and confirm the user's password, and a button to perform the action. A text block gives us a place to display error messages to the user if needed. The onPressed event of the button is hooked up to a function called createUserAccount in the onWidgetInitialized method override. The createUserAccount method sanitizes the text from the input widgets, in this case simply removing leading and trailing whitespace, but it could be doing anything else you like, such as enforcing maximum username length, minimum password length or complexity, etc. It then calls the data access layer's function isUsernameInUse to see if the entered username is free to assign. This is not strictly necessary, as the createUser function will simply return failure state if you try to create multiple users with the same name. But we do it because we want to be able to inform the user of a specific error in this case. We then test if the 2 passwords entered by the player are the same. If not, we display that to the user as an error. And finally, when everything else is okay, we call the data access layer to actually create a new account for the user. If it reports that account creation was successful, we clean all the input boxes and broadcast to any listeners to let them know that a new account has been created, which also effectively means that user ID is now logged in. The logon widget is even simpler. It has text inputs for username and password, a button to perform the action, and a text block to notify the user that the login failed, generally because of a bad password, but for security reasons we do not give details. As before, the button's onPressed event is hooked up in the onWidgetInitialized override, which calls the function performLogin. PerformLogin calls the data access layer's test user login, passing the username and password provided by the user. It returns either the user ID of the validly logged on user or -1 to indicate a failure. In the case of a failure, the error text is displayed to the user. In the case of success, another data access layer function is called to get all the data for that specific user, and this information is then broadcast to any listeners to let them know the user is now logged in. As before, we clean the input controls. The Details widget is used to display the currently logged in user's information. We have widgets for displaying the username and tagline, and in addition to this, a button to allow the user to choose to log out. As before, the button's onPressed event is hooked up in onWidgetInitialized to a function performLogout. This function clears the text from the display widgets and broadcasts to any listeners the user ID of the user that was just logged out. Usually, listeners won't be interested in a specific user ID at this point, but it's there just in case. This widget overrides the method onUserAccountSet provided in the base class to perform setting the display widgets whenever a user is effectively logged in. The Edit widget lets a user change their tagline and username as long as the username they want isn't already in use. Text inputs for the new username and tagline are provided, along with a password confirmation just to be on the safe side. A button lets the user submit the action, and text blocks are provided to confirm successful changes as well as notify of errors. The button event is hooked up in the now familiar manner to a function called SaveChanges, which first checks with the data access layer to see if that username is already in use by any other user than the one making the request before calling the data access layer's edit user account function to actually perform the change. If the change is successful, a broadcast notifies any listeners that the currently logged in user's details have been edited so that they can update what they are displaying. The Changing Password widget is also pretty simple, as it doesn't display any user details. It just needs input to validate the current password and take the new password and the confirmation of the new password, plus of course a button to actually fire off the action as usual. We check that we have a currently logged in user, something we shouldn't need to do, but just in case someone inadvertently displayed the widget in the wrong place, it gives us a modicum of extra protection. And of course we check that the new password and the confirmation are the same, just as when we created the account. Messages are displayed to the user in the case of success or failure, but nothing is broadcast. The user was logged in prior to this function and is still logged in after it, so there is simply no need. And of course the Delete widget. Really simple one, just a password confirmation and a button to perform the action. You could, if you wanted, add a layer onto this, asking the user to confirm that they really wanted to do it. But come on, they needed to re-enter their password to actually do it, so, you know. As a small extra point here, for some online systems, you can, when a user chooses to delete something, instead mark the record somehow, an is deleted boolean, or a value in a bitflags field, or even a delete requested date time field. And then, in your queries, simply filter these records out so they're not displayed or used. Later, you can have an automated process actually perform those deletions for real after a specified cooldown time, allowing a user who deleted their account by accidentally clicking the delete option and then accidentally entering their password and subsequently accidentally hitting a button marked delete to confirm the action to contact your support department and potentially get their account reinstated. Of course, if you choose to do this, you need to make it clear to the user in question that it's basically magic that allowed you to reconstruct their account data, at great financial and emotional expense, at the cost of the lives of many innocent small animals which had to be sacrificed to permit the magic to happen, and that they are very, very lucky. So, we now have a bunch of widgets which perform our desired actions. What are we going to do with them? That's really up to you. You might place them, as appropriate, on a user account menu area of your settings system. I will just demonstrate how we can create a main user account widget that simply pulls all the individual ones we've made together into one place and shows the appropriate things based on the user's logged in state. I'm going to make use of the Widget Switcher widget. That's kind of weird to say. If you're not familiar with it, you can think of it a little bit like a tabbed control, popular in Windows development environments like VB.NET, C# or Delphi. You can see something like it when you open the property pages for a file on Windows. It's a container widget like the canvas panel or the horizontal box, so you add widgets to it. Each widget you add is assigned a zero-based index in the order you add them. or rearrange them into. The widget switcher has an active widget index property. Changing this value will cause the widget assigned to that index to be displayed and the others hidden. The thing is, you don't get any actual tabs or buttons with it, because this is for games, and your specific UI decisions might be very different from other creators, so you're going to need to provide your own. Here, I choose to keep it simple by using the standard Unreal button widgets, simply containing a text block with some text. Because that's all based on ftext, it means you can have it all multi-language without too many issues. Of course, my sample layout has plenty of issues. For example, I have labels to the left of the text boxes, something that's considered generally bad design, or just looks stupid on right to left languages like Hebrew, Arabic, or Urdu, for example. But this is just an example, so I'm giving myself a pass this time. Okay, let's road test that little lot and see it in practice. Let's assume we don't have any user accounts in the database yet, so we can't log in. I'll create a new account. Give it a username of new user. And put something in the tagline. Same thing twice in the password fields. And hit create. Account creation successful, which takes us to the logged in user view. We can see the current account details at the top, along with the logout button, and we have options to edit, change password, and delete account. I'll click the logout button and try logging in again with the new account. Firstly, I'll try entering the wrong password. Okay, no login, that's good. And now the correct password. Logged in again. Let's have a go at editing the account. I'll change that tagline. Confirm the password. And then save the changes. Nice. The record's updated in the database, and the user details widget was automatically refreshed to display the latest values. So let's try deleting this account. I'll select the delete account option, enter the password, and click the confirm deletion button. The account has been deleted, we are now logged out, and returned to the appropriate view. Obviously, for something you are going to use in a published game, I hope you would conduct some more robust tests than this. You can run automated unit tests on the queries and the data access layer functions before you even consider letting users test the UI. In this video, we went through the entire process of making a database-backed user login system for our Unreal games. Although we used examples with the SQLite database for the sake of simplicity, it would work equally well with client-server databases, which I'll focus on more in future videos. Admittedly, this video was quite long because we covered every stage of the process from data conceptualization through to user interface creation, plus maybe I went off on a couple of tangents. Once you understand what is involved, it's actually fairly simple to grasp. If you have any comments, questions or suggestions, come and join the Discord server, link in the description. So, until next time, I wish you every success with your own game projects.